Hello and welcome to the fifth session of Introduction to MCNP course. Today we're talking about complex geometrical configuration. Let's see this configuration that we have here. This is a simple field rod, but a little bit more complex than the other one we have described in the simple geometrical configurations. Here the red zone is the fissile material zone. After that we have the helium gap. After that we have the clad, and those are support plates. Let's see here that there is a tolerance between the support plates and the fuel rod. Half of this tolerance is filled with water because this is the water level, specifying the level of the water in the box that includes this fuel rod, and the other one is air, can be modeled as void. First, to solve this problem, we have to make our surface card for each single field cell. Let's say 100 CZ, let's say 0.35 centimeters. Then 110 will be PZ, plane perpendicular to the Z axis. Let's say this sphere rod is about 300 centimeters, therefore it will be positive if we want it to be concentric about the center. Therefore it will be, let's say, negative 150 centimeters, and 120 PZ, plane perpendicular to the Z axis, at 150 centimeters. That's what we are describing right now, or what we want to describe right now, this fuel rod. This is the 120, this is the 110, and this is the 100. Let's get the cell card. First, let's introduce the cell number, then the material number, which we assume that it will be uranium isotope of 235, which have its density of 18 grams per centimeter cube. And then let's say inside the surface 100, which is inside the cylinder, and the negative direction of the plane 120, and the positive direction of the plane 110. Its importance of neutrons is 1. This is cell 1. Let's see cell 2. We have first to specify the materials of cell 2. Let's give it the base 200. 200 CZ, let's say 0.4 centimeters. 210 PZ, let's say negative 151. 220 PZ, let's say positive 151 also. And there's our helium gap enclosing our fuel rod. So this is the plane 220. This is the plane 210, and this is the cylinder 200. Then after that, let's specify its cell card, which will be, let's give it the material number 11, negative 0.0045, since it's helium, so it has low density. Then it will be negative 200, inside the cylinder called 200, positive in the positive direction of the plane 210, negative direction of the plane 220, excluding all which is in cell 1, and the importance of neutron equals 1. After that, we have to specify the materials, the surface card of the clad, which will give the base 300. Let's see. Of course, it will be CZ, let's say 0.5, then 310 PZ, let's say 155. But if we focus on the schematic here, we'll find that the bottom line or the bottom plane of the helium gap is the same as that of the clad. Therefore, we can use the surface 210 in the clad. Let's see our cell card. Our cell card will be, let's give it the number 3, material 12, negative 2.7, which means that this material is aluminum. Let's see, beside the cylinder 300, in the negative direction of the plane 310 and in the positive direction of the plane 210, excluding cell 1 and cell 2, importance of neutron equals 1. In this step, that's what we have done. This is our fissile column, and this is the clad. What we have done is that we have, this is the gap, and here's the clad. After that, we have to take care of the tolerance. Tolerance can be modeled using a cylinder. The cylinder will be divided into two axially, where this could be a cell and this must be another cell because due to the difference in the material. Therefore, now we're going to describe the tolerance. It can be like CZ, let's say 0.6, or 110 will be PZ, let's say at the level 0, if you want the water level to be exactly at the center. Maybe we can make it above it a little, so it can be like 30, plane perpendicular to the z-axis at 30 centimeters, and the bottom line is the same as that of the helium gap and the clad, so we can use the surface 210 again. Therefore, here cell 4, let's give the water material 13, show a density of gram per centimeter cube, negative 400, negative 400, positive 210, and negative 420, negative 410, excluding cells 1, 2, and 3, and the importance of our neutron equals 1. After that, we have to specify the another part of the tolerance, which will be void, therefore zero material, which means that there is no density, to be negative 400, negative, let's see what this surface was. This surface was 310. I'm talking about this surface. Therefore, negative 400, negative 310, and in the positive direction of 410, excluding the cells 1, 2, and 3. Importance of our neutron equals 1. Let's get to those 4 support plates. Those 4 support plates can be defined by 6 planes each. 2 plates can be defined by 6 planes. In this case, this plane was already defined, therefore we need here about 5 planes, and in this case 4 of those planes were defined in the bottom plates, which are planes perpendicular on the x and planes perpendicular on the y. Therefore, the only difference will be the z plane, and this is one of them already defined. Therefore, we will define the another one. Let's check the bottom support plates. First, 500 plane perpendicular on the x-axis at, let's say, negative 1, 510 plane perpendicular to the x-axis at 1, 520 plane perpendicular on the x-axis at plane perpendicular on the y-axis at negative 1, 530 plane perpendicular on the y-axis at 1, then 540 plane perpendicular on the z-axis at, let's say, the thickness is 1 centimeter, and this bottom plate was 210. Therefore 210 was negative 151 centimeters. Therefore it will be negative 150 centimeters already defined in the 110 plane in here. Therefore, we may not use the plane perpendicular on the z-axis at all for describing the box. So let's see the cell card. The cell card will be, let's give it the number 6, and let's give it the same material of the clad, negative 2.7. It will be 500, negative 510, positive 520, negative 530, according to the planes used. After that, we have to specify the z direction, which will be positive 100 and negative 110, and the positive direction of 210, excluding the cells 1, 2, 3, and 4. Importance of neutron equals 1. Then after that, the cell 7 will include the void. Sorry, it's probably the void. We are describing the support plates. Also 12 is 2.7. Let's say 500, negative 510, 520, negative 513. Let's check the z. The z will be negative 310, negative 310, and we'll have to specify another plane, which will be 540 pz at 154 centimeters in order for this thickness to be 1 centimeter. Well, we said its number was 540, therefore the positive direction of 540, excluding the cells 1, 2, 3, and 5, because the cell 5, this is the cell 5, while this is the cell 4, and currently we are describing the top plates, while in cell 6 we were describing the bottom plates. After that, now we have the top plates, bottom plates, special column, helium gap, and clad. Now we want to make the complete box. This complete box have to be also divided into two. One of them includes water, and the other consists of void. Therefore, first we have to specify the planes that we will use, the planes perpendicular on the x-axis, y-axis, and z direction. Let's give it the base 600 px. Let's say the 2, its dimension is 4 by 4, 610 px to 620 py negative 2, 630 py 2, and then 640 pz, let's say 200. After that, I have to specify the two cells describing this geometry, which will be cell 8. Don't forget here to include the importance. Cell 8 will include, let's say, it will be the bottom part, which includes water. Therefore, its material will be 13, its density will be 1 gram per centimeter cube. Let's say 600, negative 610, 620, negative 630. And this plane was called 210, as far as I remember. It was called, yes, 210, which means in the positive direction of 210 and in the negative direction of this plane, which was called this plane was called 410. Negative direction of the plane 410, excluding cells 1, 2, 3, 4, and 6. Importance of neutron equals 1. After that, therefore, this is cell 8. We have here cell 9. For cell 9, this consists of what? There's no density. Say 600, negative 610, 620, negative 630. In the positive direction of 410 and in the negative direction of 640. Here's 640. Excluding the cells 1, 2, 3, 5, and 7, and of course the neutrons. Neutron, importance of the neutron equals 1. After that, let's describe the void cell, which will be 0, 600, the negative direction of 600, the positive direction of 610, union, all of these are unions, the negative union in the negative direction of 620, union in the positive direction of 630, union in the positive direction of 640, union in the negative direction of 210. Importance of the neutron equals 0. Here's the last cell at what we were describing, anything that is here, 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 or here. Here's the importance of neutron equals 0. Let's just write any data card for us to show to be able to write this code on the visual editor to see the geometry and check if there's any errors. Let's see data card will be something like let's say 10, which was the cycle 92 to 35, 100%, 11 to 004, which was helium, 100%, 12, which was the clad, 13, 027, aluminum, 100%, 13, which was the water, let's say 1001, 0.67% atomic fraction is hydrogen, and 33% was oxygen. And of course, don't forget the material treatment of light water was different in the calculations. Let's write this code in a text file and check whether it works or not. First, let's start with the cell card. Title card, complex geometrical configuration. Let's write the surface card. CZ 0.35, 110, PZ negative 150, 120, PZ 150, 100, CZ 0.4, 210, PZ negative 151, 220, PZ 151, 300, CZ 0.5, 310, PZ 155, 400, CZ 0.6, 410, PZ 30, after that 500, PX negative 1, 510, X1, 520, PY negative 1, 530, PY 1, 540, PZ 154, 600, PX negative 2, 610, PX 2, 620, PY negative 2, 630, PY 2, and finally 640, PZ 200. This is the data card was M10 92 to 35 1, M11 2004 1, M12 13 027 1, M13 1001 0.67, and 8016 0.33, MT13 was light water treatment, and there's a simple data card. It's not complete, of course the code won't run because it's not complete, but that's just for us enough to show us the how. the geometrical configuration. First cell was of material 10, density 80 gram per centimeter cube, negative 100, negative 120, 110. Importance of neutrons equals 1, 2, 11, negative 0.0045, negative 200, 210, negative 220, excluding cell number 1. Importance of neutron equals 1. Cell number 3 consists of material 12 of density negative 2.7 gram per centimeter cubes, negative 300, negative 310, positive 210, excluding 1 and 2. Importance of the neutron equals 1. Cell 4 or the material 13 of density 1, which was water, negative 400, 210, negative 410, excluding the cells 1, 2, and 3. Importance of the neutron equals 1. Cell number 5 was a void, negative 400, negative 310, positive 410, excluding 1, cells 1, 2, and 3. Importance of neutrons equals 1. Let's see, cell number 6 was a material 12, which its density was 2.7 grams per centimeter cube, 500, negative 510, 520, negative 530, negative 110, positive 210, excluding the cells 1, 2, 3, and 4. Importance of neutron equals 1. Cell number 7, 12, 2.7, 500, negative 510, 520, negative 530, negative 310, positive 540. And excluding the cells 1, 2, 3, and 5. So neutron equals 1. Cell number 8 was water. Surfaces 600, negative 610, 620, negative 630, 210, negative 410, excluding cells 1, 2, 3, 4, and 6. Importance of neutron equals 1. Cell number 9 was of void material, 600, negative 610, 620, negative 630, 410, negative 640, excluding the cells 1, 2, 3, 1, 2, 3, and 9, 1, 2, 3, 5, and 7. Importance of neutron equals 1, and finally cell number 10 was void, and it consisted of negative 600, 610, area 620, 630, 640, negative 210, because the importance of neutrons equals 0. Let's just make sure that we have copied the hash port correct in all the cells. Hash 1, hash 1, hash 2, hash 1, hash 2, hash 3, hash 1, hash 2, hash 3, hash 1, hash 2, hash 3, hash 4, hash 1, hash 2, hash 3, hash 5, hash 1, hash 2, hash 3, hash 4, hash 6, hash 1, hash 2, hash 3, hash 5, hash 7. Correct, I suppose. Let's just make overlay name MCNP example and call this file 1. Let's open this file in the visual editor to check whether it's correct or not. MCNP example, and here's the file 1. Let's just zoom a little bit on this geometry to check if it's correct or not. Have it colored. The white color means valid, that's correct, and let's check this port. Here's the fissile column, here's the helium gap, and there's the clad. The support plates are of the same material of the clad, and there's the tolerance when in the void part. And let's zoom downward to see if it's correct or not. Before there's the water. There's the water, and there's the tolerance, clad, the gap, the fissile column. And here, let's check this out. There's the support plates, the same material of the clad. Now we have verified that this model works correctly. Thank you all for following this video.